Good morning, students. Let us continue from where we have stopped yesterday. So, you are all requested to watch the previous video before you continue watching this video. So, the fifth question is, if C is the center, A dash, B dash are the major and minor axes of the ellipse x square by a square plus y square by b square equals to 1. If Pn is the ordinate of a point P on the ellipse, then show that this is equals to this. We need to show. So let us take the ellipse. So this is our ellipse. So this is x dash, y dash. Now this C be the center of the ellipse, whose center is at the origin for the standard form of the ellipse. A comma A dash are the points on the major axis. Here the major axis is along x axis. A is greater than B. This is B dash, minor axis. So here A dash is the major axis and B dash is the minor axis. So Pn is the ordinate. So let us take the parametric point on the ellipse. So let P theta, A cos theta, B sin theta be any point on the ellipse. So let us take this point P. So this is P, A cos theta, comma, B sin theta. So I'll draw a perpendicular from P onto the major axis. So Pn. Pn is the perpendicular of P on the major axis. So then, since C is the center of the ellipse, therefore this Cn is equals to A cos theta, and this Pn, which is B sin theta here. B sin theta. So what is Pn here? Pn is the ordinate of P, that is y coordinate, B sin theta. So let us write that. So here Cn is equals to A cos theta, Pn is equals to B sin theta. Next step, B A dash is equals to A dash is equals to 2A, B dash is equals to 2B. That means this is A comma 0, this is minus A comma 0, this is 0 comma B, this is 0 comma minus B. So here BC is equals to, this is B, and CA is here, CA is equals to CA dash is equals to, CA is equals to CA dash is equals to A, and CB is equals to CB dash is equals to B, and BC is equals to, for BC, CA both are equal, and here AN, here AN can be written as CA minus CN is AN. So to obtain AN, CA minus CN. CA minus CN. What is CA? CA is A. So minus Cn. Cn is how much? Cn is equals to a cos theta. So which we have written before, a cos theta. Likewise, what is a dash n? A dash n. So this a dash n is nothing but ca dash plus cn. Ca dash plus cn. So ca and ca dash both are a. Therefore, ca dash is equals to a here plus cn is equals to a cos theta. A cos theta. Therefore, we have everything here. Now, so RHS, I'll take RHS is BC square by CA square. What is BC here? BC or CB is what? It is small b. So this is B square by CA is A. So A square. So this RHS I got B square by A square. Now this also B square by A square is what we need to prove. So for this I take LHS. So Pn whole square by A dash n into An. So what is Pn? Pn is B sin theta. So this is B sin theta whole square by A dash n is A plus A cos theta into An is A minus A cos theta. A minus A cos theta. So this is B square sin square theta by A plus B into A minus B. A square minus B square. So this is A square minus A square cos square theta. So B square sin square theta by, so take A square in common. So A square into 1 minus cos square theta. 1 minus cos square theta is sin square theta. Therefore this is A square sin square theta. So this is equals to B square by A square. Therefore LHS and RHS is B square by A square. Therefore this is proved. S and T are the foci of an ellipse and B is one end of the minor axis. If SDB is an equilateral triangle, then find the eccentricity of the ellipse is what we need to find. Eccentricity of this ellipse. So let the equation of the ellipse be x square by A square plus y square by B square equals to 1 with A greater than B. So if A greater than B is the case, then the supposed ellipse is this. This is our supposed ellipse. Now, so this is A dash, B dash. This is major axis and this is minor axis. C be the center. So this is, now here S comma T are the foci. So let us suppose this S and this is T. So let, given that S is AE comma 0, this is minus AE comma 0. Given that S AE comma 0 and T minus AE comma 0 are the foci of the given ellipse. Because for the ellipse x square by A square plus y square by B square equals to 1 with A greater than B, so foci are S and S dash. Here instead of S dash he has given T, which is plus or minus a comma 0. A comma 0 minus a comma 0. Now, here, one end of the minor axis is B. B is one end of the minor axis. B dash is another end, but that is not given. So, given that B is one end of the minor axis. Here, STB is in equilateral triangle. This. Given that. So, for the ellipse x square by a square plus y square by b square with a greater than b, this b is 0 comma b and this is 0 comma minus b. B dash is. Now, given that STB is an equilateral triangle. That means in equilateral triangle, this angle is 60 degrees, and so all sides are, lengths of all sides are equal. So SB is equals to BT is equals to ST. So let us take SB is equals to ST. Squaring on both sides, SB square equals to ST square. So SB square is nothing but AE minus 0 whole square, distance between the 2 points S and B. So AE minus 0 whole square plus 0 minus B whole square is equals to ST square. So distance between S and T, distance between the foci, AE minus of minus. So AE minus of minus is AE plus AE whole square plus y2 minus y1, 0 minus 0 whole square. This is equals to, this is A square E square, this is B square, this is AE plus AE 2AE whole square, which is 4A square E square. From this, B square is equals to 4A square E square minus A square E square is 3A square E square. We know that B square is equals to A square into 1 minus E square. For the parabola A greater than B, B square is equals to A square into 1 minus E square, that we know, which is equals to 3A square E square. So this is equals to A square minus, so otherwise from this, A square gets cancelled. This implies 1 minus E square is equals to 3E square. From this, 1 is equals to, this minus E square when transposed onto another side, this is 4E square. So 1 by 4 equals to E square. Therefore, E square equals to 1 by 4, where E is equals to 1 by 2 is the eccentricity of the ellipse. The orbit of the Earth is an ellipse with the eccentricity 1 by 60 with the Sun at one of its foci, the major axis being approximately 186 into 10 power 6 miles in length. Find the shortest and longest distance of the Earth from the Sun. We know that the path of the orbit of the Earth is ellipse. So, let us suppose that this is the orbit of the Earth. So, now, this being the center of the ellipse, and let S comma S dash be the foci of this elliptical orbit. So S is the position of the Sun. Let us suppose that this is the Earth. So the position of the Earth is here. Let S be the position of the sun. Let S be the position of the sun. Let E be the position of the earth. Let the orbit of the earth be x square by a square plus y square by b square is equals to 1. What is given is the major axis being approximately 186 into 10 power 6. Major axis means what? A dash. A dash being the major axis and B dash being the minor axis. Given that the length of the major axis is A dash, which is equals to 2A, that is given as 186 into 10 power 6 miles. So 2A is this, therefore A is equals to 186 by 2, which is 93 into 10 power 6 miles. Given eccentricity E is equals to 1 by 60 is given. Now we know that the shortest and longest distance from the sun is A and A dash. From the sun is A and A dash. That is SA. So SA being the shortest distance. What is SA? S is AE comma 0. So this is square root of AE minus A whole square plus 0 minus 0 whole square, that is 0 anyway. So square and root gets cancelled. This is AE minus A. So AE minus A, so it could be A minus AE as well. So modulus of. So this is, we will get either AE minus A or A minus AE. So and the longest distance from the sun is SA dash. SA dash is nothing but AE minus of minus. So this will be AE plus A. These are the shortest as well as longest distances from the sun on this ellipse. Now, SA is equals to, if you take A in common, then we'll get 1 minus E. So A is 93 into 10 power 6 into 1 minus 1 by 60. E value is 1 by 60. So that is 93 into 10 power 6. 61 are 60 minus 1, which is 59 by 60. In 1, 4, 5 into 10 power 6 into 10 power 6 miles. Likewise, SA dash is equals to 93 into 10 power 6, 1 plus 1 by 60. 1 plus 1 by 60, which is 61 by 60. This is equals to 9455 miles. Now let us discuss the point of intersection of the ellipse and the straight line in a plane. So that is the relative position of a straight line with respect to ellipse. Let us suppose that this is our ellipse. So the relative position of straight line with respect to the ellipse in this plane could be either the straight line may be like this, or It may be like this or it even be like this. So depending on the discriminant. So let us see the point of intersection of the ellipse x square by a square plus y square by b square equals to 1 and the straight line y is equals to mx plus c. First, let us solve these two. How? Solving them, we get x square by a square plus y is equals to mx plus c. Substitute here. So this is mx plus c whole square by b square equals to 1. This is equals to LCM is b square x square plus a square into mx plus c whole square by a square b square equals to 1. If you cross multiply with 1, we'll get a square b square. So this is equals to b square x square plus a square into a plus b whole square. You expand. So this is m square x square plus c square plus 2 mcx. mcx is equals to a square b square. Now this is equals to x square into b square plus a square m square plus this is 2 a square mcx plus a square c square. This plus a square b square, if you transpose onto another side, this is a square into c square minus b square is equals to 0. If you see this, this is a quadratic equation in x square, x and constant equals to 0. This is a quadratic equation in x. So since this is a quadratic equation in x, this equation have got two roots. Let the roots be x1 comma x2. So if two roots, that means the two roots may be real and distinct or coincident or even it is imaginary. So depending upon the discriminant, what is the discriminant? B square minus 4ac is greater than equals to 0 or is equals to 0 or less than equals to 0. If the straight line intersects the ellipse at only one point, then that line is said to be what? A tangent to the ellipse. Therefore, this straight line will be touching to the ellipse. So now we will derive the condition for the line to be a tangent to this ellipse. So is what? B square minus 4ac equals to 0. So what is b square here? So this is ax square plus bx plus this is all c. So ax square plus bx plus c equals to 0. So the discriminant is b square minus 4ac equals to 0. So the objective to behind doing this is we are trying to establish a relation when this straight line touches this ellipse. Now What is b square here? What is b? This. B square is 2a square mc whole square. So this is 4a power 4 m square c square minus 4 ac. A is this b square plus a square m square. C is a square c square minus b square is equals to 0. This implies, so 4a square if you take common, then we will have here a square c square m square. So 4a square we have taken common, therefore here we are getting a square m square, a square m square c square, a square m square plus b square. 4a square we have taken common, so we are left with a square m square plus b square into c square minus b square is equals to 0. So this 4a square if you transpose onto another side, it will be simply 0. This implies a square c square m square, this is minus a square m square c square, a square m square c square. Next, minus this is equals to a square m square c square minus a square m square b square plus b square c square minus b power 4 equals to 0. So this is equals to a square c square m square minus a square m square c square. These two gets cancelled. So minus into minus plus a square m square b square. So minus b square c square minus into minus plus b power 4 equals to 0. B power 4 is equals to, this is, if you transpose onto another side, this is b square c square minus a square m square b square. So this is b square into b square is equals to, take b square in common in both of them, then this is c square minus a square m square. So b square gets cancelled. So b square, this minus a square m square, if you transpose onto this another side, a square m square is equals to c square. Therefore, this is the condition for the straight line, y is equals to mx plus c to be a tangent to the ellipse x square by a square plus y square by b square equals to 1. The condition for the straight line y is equals to mx plus c to be a tangent to the ellipse. And now in this section we will be discussing the equation of the chord joining the 2 points is s1 plus s2 equals to s12, and the equation of the tangent which is s1 equals to 0, and what is the equation of the tangent at both the parametric point a cos theta b sin theta and the Cartesian point x1 comma y1, and the equation of the normal at both parametric and the Cartesian points. And see the equation of the chord joining the 2 points x1 y1 and x2 y2 on the ellipse s equals to 0 is s1 plus s2 equals to s12. This is not a new thing. This we have discussed in the circles as well as parabola. So s1 plus s2 equals to s12. So the concept is same, but the notations will be differed. So let us take the ellipse x square by a square plus y square by b square equals to 1. This ellipse, and this is the secant line. This secant line cuts the ellipse at P and the Q. So what is this PQ? PQ is the chord. What is the chord? The line joining any 2 points of the ellipse is said to be the chord. So which is S1 plus S2 equals to S12 is what we need to prove. For this, since x1, y1 is a point lies on the ellipse, so whenever a point lies on the ellipse, point has to satisfy the ellipse equation. So that means substitute x1, y1 in this ellipse, then we will be getting x1 square by a square plus y1 square by b square is equals to 1. What is this? S11. And what is since q x2 y2 is also a point on this ellipse, again substitute x2 y2 in this ellipse, because this point lies on the ellipse. Point has to satisfy the line elliptical equation. So S22 is simply substituting x2 y2 in this, which is S22. x2 square by a square plus y2 square by b square equals to 1. So this. So S11 equals to 0 and S12 equals to 0. This minus 1 equals to 0 and this minus 1 equals to 0. This is S11 equals to 0, S22 equals to 0. Because the points x1, y1 and x2, y2 both are lying on the ellipse. Now consider the first degree equation S1 plus S2 equals to S12. So S1 plus S2 equals to S12. What is S1? X1 by a square plus y1 by b square minus 1 plus S2 is x2 by a square plus y2 by b square minus 1 is equals to S12 is x1 x2 by a square plus y1 y2 by b square minus 1. So this is S1 plus S2 equals to S12 full form. Now this is the equation of this chord, but on this chord P x1 y1 lies. So whenever a point lies on a straight line, point has to satisfy the equation of a line. Substituting this P x1 y1 in this, we will get, in the place of x and y, substitute simply x1 y1. So this is x1 y1 x1 y1. So we will get x1 into x1 square by a square plus this is y1 into y1 square by b square minus 1 plus this is x1 x2 by a square plus y1 y2 by b square minus 1 is equals to x1 x2 by a square plus y1 y2 by b square minus 1. See this, x1 square by a square plus y1 square by b square minus 1 is equals to how much? S11, and that S11 we have already discussed. S11 equals to 0 because the point P x1 y1 lies on the ellipse x square by a square plus y square by b square equals to 1. So substituting x1 y1 in that, x1 square by a square plus y1 square by b square minus 1 equals to 0. In that way, this is 0. This is what? Notation of S12. So S12 equals to S12. So we arrive to a conclusion that yes, the point x1 y1 lies on this equation of the chord S1 plus S2 equals to S12. So now, so similarly x2 y2 also satisfies this. How? So we can see once again. So S1 plus S2 equals to S12. The notation of S1 is, so one thing is clear that P x1 y1 lies. So that is S11 equals to 0. X2 y2 lies on this ellipse. So x2 square by a square plus y2 square by b square minus 1 equals to 0. That is S22 equals to 0. Now you take S1 plus S2 equals to S12. What is S1? X1 by A square plus y1 by B square minus 1 plus x2 by A square plus y2 by B square minus 1 is equals to S12 is x1 x2 by A square plus y1 y2 by B square minus 1. Now substitute x2 y2. Why we are substituting? Because q x2 y2 is also a point on this chord. Yes, q is a point on the ellipse, not only a point on the ellipse, but q is also a point on this chord s1 plus s2 equals to s12. Substituting x2 y2 in this. So how do we substitute? In the place of x and y, substitute x2 and y2, and let us see what will happen. So this is x2 x1 by a square plus y2 y1 by b square minus 1 plus this is x2 into x2 x2 square by a square y2 into y2 y2 square by b square minus 1 is equals to x1 x2 by a square plus y1 y2 by b square minus 1. So x2 square by a square plus y2 square by b square equals to b square minus 1 is what? S22. So what is f2 x1 by a square plus y2 y1 by b square minus 1? This is S21 plus this is x2 square by a square plus y2 square by b square minus 1 is S22, which is 0, is equals to this is S12. S21 and S12 are both equal. That means S12 is equals to S12. So that means equation gets satisfied. Why? Because QX2Y2 is also a point on the equation of the chord joining the 2 points. Therefore, equation of the chord PQ is S1 plus S2 equals to S12. After this, we will be deriving the equation of the tangent at Px1 y1 to the ellipse is S1 equals to 0. That's what we have proved in circles as well as parabola. So what is the equation of the tangent? First of all, what is the tangent? This PQ is the chord. So this PQ is a chord. This chord becomes a tangent if and only if Q approaches to P. Q approaches to P. So that means if Q approaches to P, then actually this chord becomes the tangent like this. So that's what we will be discussing. So now the equation of the tangent at Px1 y1 to the ellipse s equals to 0 is s1 equals to 0. So before we have seen this. This is the ellipse and this PQ is the chord. And this PQ chord will become a tangent. That means this line will touches the ellipse at this point P as Q keeps on approaching to P. So that means QX2 Y2 is tending towards X1 Y1. So let us take since Px1 Y1 and Qx2 Y2 are lying on the ellipse. So substitute x1 y1 on the ellipse, x square by a square plus y square by b square minus 1 equals to 0. Substitute x1 y1, then x1 square by a square plus y1 square by b square minus 1 equals to 0, which is s11 equals to 0. Likewise, qx2 y2 lies on the ellipse, s22 is also equals to 0. And we have seen this equation of this chord joining the points P and Q is S1 plus S2 equals to S12. This chord becomes the tangent at P when Q approaches to P. That is QX2Y2 approaches to PX1Y1. So this is what we have seen earlier. S1 plus S2 equals to S12. So Q is tending towards P. So limit Q is tending to P. That means S1, this S2 also becomes S1 because x2 y2 is tending towards x1 y1. So this S2 becomes S1, and this S12 becomes, in the place of 2, we will get 1. So S1, this 2 becomes 1, this 2 becomes 1. So S1 plus S1 is equals to, S1 is already there, this 2 becomes 1 because Q is tending to P. So S1 plus S1 is 2S1. 2S1 is equals to S11. What is this S11? As we have seen it before, 0. Why? Because Px1 y1 lies on the ellipse x square by a square plus y square by b square equals to 1, or minus 1 equals to 0. So this is what we will be getting. Therefore, this is how much? S11, which is equals to 0. This is S11 and this is equals to 0. So 2S1 equals to 0, then S1 equals to 0. And what is this notation? S1? Xx1 by a square plus y by 1 by b square minus 1 equals to 0. Therefore, the equation of this tangent, is x1 equals to 0, which is xx1 by a square plus y by 1 by b square minus 1 equals to 0. And what is the equation of a normal? First of all, what is a normal? This is a tangent. So tangent is a straight line. So normal is a line. Normal is a line which is passing through this P, where this line touches the ellipse. So this line passing through this point of contact and perpendicular to this tangent. Therefore, this is called normal. And this is what? Tangent. So we will also derive the equation of the normal at Px1 y1. Also, the equation of the normal at Px1 y1 to the ellipse x square by a square plus y square by b square equals to 1 is a square x by x1 minus b square y by y1 is equals to a square minus b square. So let us prove this. So this is equals to, so first of all, the equation of the tangent at Px1 y1 to the ellipse s is equals to 0 is s1 equals to 0. So the notation is xx1 by a square plus y1 by b square is equals to 1, or minus 1 equals to 0. So this is b square xx1 plus a square y1 minus a square b square equals to 0. I found the LCM, a square b square. So this is what we have obtained. So now slope m equals to minus a by b minus coefficient of x by coefficient of y. What is the coefficient of x? b square x1 by a square y1. So what is the slope? M dy by dx at x1 y1. M at x1 y1 is minus a by b. Slope m at x1 y1 is m equals to minus a by b. So minus coefficient of x by coefficient of y. So this is b square x1 by a square y1. So this is the ellipse and this is our tangent. This is our tangent, and the slope of this tangent is this. But normal is a straight line which is perpendicular to this tangent. So this normal is perpendicular to the tangent and passing through the point of contact of the line and the ellipse. So now equation of normal at px1 y1 is, at this point px1 y1, equation of the normal is, we have a point and the slope of this normal is this. So slope point form, y minus y1 equals to m into x minus x1. So y minus y1, m is this. This is the slope. This is the slope of the tangent. But while slope of the normal is equals to, so reciprocate and change the sign, then we'll get a square y1 by b square x1. So this is the slope of the tangent while this is the slope of a normal. Then this is a square y1 by b square x1 into x minus x1. So this is equals to b square y x1 minus b square x1 y1 is equals to a square x y1 minus a square x1 y1. So this is equals to b square y x1, this a square x y1, if you transpose onto this side, minus a square x y1 is equals to this minus b square, if you transpose onto another side, that is b square x1 y1 minus a square x1 y1. Take x1 y1 common, then b square minus a square is what we get. So this is equals to, now keeping this on the other side, divide it with the x1 y1. So b square y x1 by x1 y1 minus a square x y1 by x1 y1 is equals to b square minus a square. So that is equals to, so here y1 gets cancelled, x1 gets cancelled, we get b square y by y1 minus a square x by x1 equals to b square minus a square. If you take minus common, then we'll get minus of a square x by x1 minus b square y by y1 is equals to minus of a square minus b square. So minus gets cancelled on both the sides. Then we get a square x by x1 minus b square y by y1 equals to a square minus b square is the equation of this normal at this point p x1 y1. So far we have seen the equation of the tangent and normal at the Cartesian point x1 y1. Now let us derive the equation of the tangent and normal at the parametric point. What is the parametric point of the ellipse? A cos theta, comma b sin theta. So equation of the tangent at the parametric point a cos theta b sin theta to the ellipse s equals to 0 is x cos theta by a plus y sin theta by b equals to 1. So how do we derive this? First equation of the tangent at px1 y1 to the ellipse s equals to 0 is s1 equals to 0. So this is x1 by a square plus y1 by b square minus 1 equals to 0. Now what is the parametric point? A cos theta, b sin theta. This is x1 and this is y1. So this implies x1 is a cos theta by a square plus y b sin theta by b square minus 1 equals to 0. So this b gets cancelled. This a gets cancelled. Therefore we get x cos theta by a plus y sin theta by b equals to 1. So now let us see the equation of the normal at the parametric point a cos theta b sin theta to the ellipse s equals to 0 is ax by cos theta minus by by sin theta is equals to a square minus b square. So first of all, what is the equation of the normal at the Cartesian point px1 y1 is a square x by x1 minus b square y by y1 is equals to a square minus b square. At the parametric point px1 y1 is a cos theta b sin theta. Substitute a square x by x1 is a cos theta minus b square y by y1 is b sin theta is equal to a square minus b square. So this a gets cancelled, b gets cancelled. Therefore we get x by ax by cos theta minus by by sin theta is equals to a square minus b square. Now let us see the condition for the line y is equals to mx plus c to be a tangent to the ellipse x square by a square plus y square by b square equals to 1. So already we have proved the point of intersection of a straight line and the ellipse. Then we get one quadratic equation, and that quadratic equation's root we have assumed to be x1 and x2. The discriminant b square minus 4ac we have considered it equals to 0. The previous class we have done all these things, but now let us do the same concept but by equation of the tangent concept, which is s1 equals to 0. So that means this is the ellipse and this is our straight line. This is our straight line. Y is equals to mx plus c, and this is x square by a square plus y square by b square equals to 1. So let this be p x1 comma y1, the point of contact of the ellipse and the straight line. So given straight line, given equation of straight line is y is equals to mx plus c. So this can be written as mx minus y plus c equals to 0. Given equation of ellipse is x square by a square plus y square by b square is equals to 1 s. Let p x1 y1 be the point of contact of straight line and ellipse. So at Px1y1, what is the equation of the straight line? What is the equation of the ellipse? Equation of ellipse at Px1y1 is s1 equals to 0. That is xx1 by a square plus yy1 by b square minus 1 equals to 0. So this is the equation of a tangent at Px1y1 to the ellipse s equals to 0. So, and since this line is passing through x1y1, since Px1y1 since y is equals to mx plus c is passing through this straight line is passing through Px1y1, then it implies y1 equals to mx1 plus c. So this 1 and this 2, y is equals to mx plus c is this straight line, but whereas equation of the tangent at Px1y1 to with respect to ellipse is s1 equals to 0. So 1 and 2 represents the same straight lines. 1 and 2 represents same straight lines. So let us compare. Comparing, we get, so here coefficient of x is x1 by a square by m is equals to coefficient of y is y1 by b square by minus 1. Y coefficient is minus 1 here, and constant here is minus 1 by, this is c. So this is what we have got. Now this is equals to, so this is equals to x1 by a square m is equals to y1 by minus b square is equals to minus 1 by c. A by b by c, a by bc. So this is what we got. This is equals to x1 by a square m is equals to minus 1 by c. From this, x1 is equals to minus a square m by c. x1 is equals to minus a square m by c. And y1 by minus b square is equals to minus 1 by c. So this is equals to y1 is equals to b square by c. So therefore x1 y1 point is this. But so the px1 y1 is equals to how much? Minus a square m by c comma b square by c. This is the point of contact. This is the point of contact of both the straight line and the ellipse. Now, since Px1 y1 lies on the, so this Px1 y1 lies both on the ellipse as well as the straight line. So lies on straight line So y1 equals to mx1 plus c. Y is equals to mx plus c. Since this is passing through px1, y1. So since point lies on the straight line, point has to satisfy the line equation. In the place of y, substitute y1. In the place of x, substitute x1. So this is equals to, so y1 equals to how much? B square by c m into x1 is minus a square m by c plus c. So this is equals to b square by c is equals to, this is minus a square m, this is minus a square m square by c plus c. So if you take an LCM here, c is LCM, minus a square m square plus c square is equals to b square by c. So c on both the sides gets cancelled. C square is equals to a square m square plus b square. This is the condition for the straight line y is equals to mx plus c to be a tangent to the ellipse. So this is what we have proved it before also. The previous class, according to the concept of a discriminant b square minus 4ac equals to 0 is what we have obtained this. So according to the equation of the tangent at px1 y1, which is s1 equals to 0 also, we got the same. Now, so therefore, equation of the tangent in the slope form is y is equals to mx plus c. So y is equals to mx plus c is equals to how much? Square root of a square m square plus b square. C square is this. C is equals to plus or minus square root of a square m square plus b square. So this is the slope form of the tangent to the ellipse. So the same concept, the slope of the tangent to the parabola also we have discussed it before. Y is equals to mx plus a by m. We have discussed for circle also. Y plus f equals to m into x plus b plus or minus r into square root of n 1 plus m square. Or y is equals to mx plus or minus r into square root of 1 plus m square for the circle x square plus y square equals to a square.